Hello everyone, Mr. Sewell here with your overview, or not your overview, but your explanation video on the moon and tides. So let's dive right into this. I hope to be able to explain some of the concepts. This first slide here takes a look at the structure of the Earth and the moon internally. Now these things are not to scale. The moon is not larger than the Earth. The moon is much smaller than the Earth. It's about 1/4 the size of the Earth. And of course it revolves around the Earth. Now this slide shows you the differences and the similarities between the Earth and the moon. And so you can read through these. Now this is a pretty neat little video here. I'll let you watch it, but it's only about 2 minutes long and it's worth the watch. But it shows how the scientists believe that the moon formed. And you can see that it formed when a Mars-sized planet struck the Earth about 4.5 billion years ago, and some of the debris collected from that impact and coalesced and formed the moon. So I'll let you watch that video. Like I said, it's a pretty cool little video. It's only a couple minutes long. The lunar surface of the moon, you've got lots and lots of craters. You've got an area called the Maria, which are smooth, dark areas of the moon made of dark, solidified lava from the moon's core. So at one time, the moon was volcanically active, but it is not at this point in time. There is water on the moon. You can find water at the poles. And NASA is really interested, terminal pointer, NASA is really interested in the water on the moon because this would allow scientists to stay on the moon for extended periods of time. You can only carry so much water and supplies into space, but if there's a supply there, then you can stay for much longer. And here you're looking at the poles. This is the south pole of the moon, and you can see the blue areas here are water, and then here's the north pole, and there's some blue areas there that are frozen. So why does the same side of the moon always face us? It's because the moon is rotating and revolving at the same time. And so the moon, it takes about 27 days for the moon to rotate once. Now the Earth rotates every 24 hours, but the moon does its rotation much slower. So as the moon moves around the Earth, which takes about a month, roughly 27 days, it also spins once every 27 days. So basically the same side of the moon is always facing the Earth. And so this is the common view that you have, and this is what they call the old man in the moon. And this is the side of the moon that you don't see. Or sometimes we call it the dark side of the moon. And so because of the moon has no light of its own. It reflects the light of the sun. So all these different phases of the moon are based upon where the moon is throughout the month and how much sunlight it's receiving. So you can see if here's the Earth and the sun is over here. And so at this point in time, this side of the moon is being lit up and the front side facing the Earth is not. So we call this a new moon. A new moon, you don't see the moon at all. It's totally dark. And so as you go throughout the month, you'll get different phases of the moon. You get crescent moons, quarter moons, three-quarter moons, full moons, and then you begin to get more crescents as the angle of the sunlight on the moon begins to change. And that's what we call our moon phases. And so you can read about that here. And again, another slide showing you the sun this time is over here, but it's basically the same information. And again, these are the different phases of the moon based upon the position of the sun. So the full moon, is the entire half of the side of the moon is facing the sun and it's lit up by the sun. Now, important concept here is how does the moon influence tides? Now tides are the movement of ocean basins, or excuse me, not ocean basins, but the ocean in the basin. And most of you know what a tide is, and typically you have 2 tides per day, a high tide and a low tide. Actually, typically you have 2 high tides per day and 2 low tides per day. So the ocean is moving back and forth inside of the bowl where all the water is. And we call that bowl the ocean basin. And so the moon influences tides a great, let me go back here. The moon influences these tides a great deal. All right, so if we take a look at our diagram here, you have the rise and fall of oceans due to the gravity of the moon. Yes, the moon's gravity is much less than the Earth, but it still does have a gravitational attraction to the Earth. And as it pulls on the Earth, the water responds to that pull. And so that's where you get your high tides and low tides. So whenever the moon is facing that particular ocean, you're going to get a high tide. Okay? And on the other side of the ocean, because the moon, or excuse me, the water is kind of sloshing on this particular side, on the other side of the ocean, you'll have a low tide. All right, so on one side of the ocean, you have a high tide. On the other side of the ocean, you'll have a low tide. And you can see that the high tides occur approximately every 6.5 hours. 6 to 12 hours, depending upon where you are. Most areas have 2 high and 2 low tides each day. These are called semi-diurnal tides. If the high and low tides differ in height, the pattern is called a mixed semi-diurnal tide. And some areas only have 1 high and 1 low tide each day. For example, the Gulf of Mexico. Those are simply called diurnal tides. So make sure that you understand these terms, particularly semi-diurnal and diurnal. Semi-diurnal, you've got 2 high and 2 low tides per day. Diurnal, you simply got 1 high and 1 low tide per day. And this graph shows you where the different types of tides occur. Now, here on the east coast of the United States, you can see we've got it outlined in red. These are semi-diurnal tides. We have 2 high and 2 low tides per day. So this graphic will kind of explain what tides are. Here's the moon. Now the moon is exerting a gravitational pull on the Earth, and like I said, the water responds to that, so you get a high tide here. But because of something called centrifugal force, and this is because Earth is spinning, it also has to do with Newton's laws of, what's the name of them? Newton's laws of gravity, or not gravity, but physics. For every action, there's an equal and opposite reaction. So as you get a bulge on this side, you're going to get a bulge on the opposite side. So you'll have a high tide here, and then a high tide on the opposite side. In the middle, right here, and on the other side of the Earth, because this is a flat image, I can't rotate it around to show it, but you would have a low tide. Okay, what we're doing is we're looking on top of the North Pole right here. We're looking on top of the Earth looking down. So if the moon is in this position, what you're going to get is a high tide here and a high tide here, and then in the middle you'll have your 2 low tides. And so as the moon moves around, when it gets over here, there will be a high tide here, and then low tides on either side. All right, and so this is kind of a diagram, kind of a crazy looking diagram that kind of shows you what I'm talking about here. The moon being over here, you get this pull on the moon, but because the Earth is spinning, you get a bulge on the opposite side. So at right angles to the bulges, you'll have your low tides. So, and like I said, as the moon moves around the Earth, the bulge or the high tide will follow the moon. Okay, again, another graphic that kind of shows you what's going on. High tides here because of the moon, high tide opposite because of the centrifugal force, low tides in between. There are 2 main categories of tides, and make sure you learn these well. Spring tides. Spring tides, you'll have your highest highs and your lowest lows. And that's because the Earth, the moon, and the sun all line up. So you get your greatest gravitational impact on the ocean basins during spring tides. And you'll find that these occur during the new and full moon phases. Okay, so whenever the sun, the Earth, and the moon is lined up, and it could be sun, moon, Earth, or it could be sun, Earth, moon. Either way, that's going to be a spring tide. And there'll be 2 of these per month. And then you have your neap tides. And that's when everything is at a right angle. You can see the different combinations here at the right angle. But you got sun, earth, and then moon at right angles to the earth. Now, because you're having competing gravitational pulls from the moon and the sun, your high tides are not going to be very high, and your low tides are not going to be very low. So you have what we describe this as having your lowest high tides and your highest low tides. So we can go back to the spring tides. This is where you have your highest highs and your lowest lows. Neap tides, you have your lowest highs and your highest lows. So you think about that. And it's all based upon gravitational pull. These also occur 2 times per month. And so here's a great little graphic that kind of shows you what's going on. You got this would be a neap tide at that position. You can see at the full moon or new moon you get a spring tide. That's a neap tide and then another spring tide. Okay, so when it's at the new moon and full moon phases, you're getting spring tides, and when it's at a half moon phase, you're getting the neap tides. Okay, and you can see the bulge, how it changes. The bulge represents the oceans. Okay, so that graphic kind of puts everything together for you. All right, that's it. That's the overview of the moon and the tides. Look forward to seeing you again in class. You got a little title activity on the haiku to complete. And if you have any trouble with that, you let me know. See ya.